Hi guys, it's Mrs. Millison. We are going to do the Check Your Understanding on page 583. Page 583. Let's read it first. A college professor suspects that students at his school are getting less than 8 hours of sleep a night on average. To test his belief, the professor asked a random sample of 28 students, how much sleep did you get last night? And here's his data in hours. Oh my gosh, that's ideal. No, I'm just kidding. Does this data provide convincing evidence at the alpha of 5% significance level in support of the professor's suspicion? So this is what your questions are going to look like. They're not going to say, state the hypotheses, go through the conditions. They're just going to say, is there convincing evidence? And again, if we reject the hoe, there is convincing evidence. But if we fail to reject the hoe, we don't have convincing evidence. So we got to go through our entire significance test to do that. Okay? So we know our sample size is 28. Now, how are we going to figure out our sample mean and our sample standard deviation? We are going to put all those numbers in the calculator, okay? So, of course, I've already done that, okay? So, let's look at my list. Got them all in there. Going to run my one variable stats. And my mean of my sample is 6.64 hours. Standard deviation is 1.9 hours, okay? And I'm good to go, okay? So, let's go ahead and do our state. Since this is means, these both have to be mu. The hoe is always equal to. And what was the claim? 8 hours, okay? He believes that kids are getting less than 8 hours. So 8 is going to be our status quo, okay? So that's what we're testing against. Now it says he believes that students are getting less than 8 hours. So we're going to do less than 8 hours because that's what we're testing against. And again, our sample was less than 8 hours, so that corresponds, so we're good to go. And of course, our alpha was 5%. Last thing we gotta do is identify mu. So this is the true population mean. Hours of sleep students are getting a night at the professor's college. The true population mean hours of sleep per night students at this college are getting. Okay, we're done with our state. Plan, of course, what's our inference method? This is just a one sample t-test. And why is it a t? It's a t because we're dealing with means. Remember, z's go with proportion, t's go with means. We'll go through our conditions. I kind of wrote down a couple of them already. Random, yeah, it stated that a random sample of students was taken. Our 10% rule, pretty sure there's more than 280 students at this college. Yeah. And of course, students are independent of each other. Now, normal, CLT is not going to work because 28 is not larger than or equal to 30. Weren't told the distribution of hours of sleep people get is normally distributed. So yes, we have to go back and we have to graph this data. But that's okay. Whoops. I got it in my calculator. Piece of cake. Oh, I didn't realize there was a glare from the light. Oh, hopefully you can see that in the calculator. Let me put it over here. Okay. Let's see. Oops, wrong thing. Let's do a box plot with the ones with outliers. It's the easiest ones to see. Zoom 9. Yeah, looks pretty symmetrical. I know it's a little to the side there, but the tails look pretty even. Okay, so I'm going to say box plot is somewhat symmetrical, or looks, roughly symmetrical with no outliers. So box plot is roughly symmetrical with no outliers. And then, of course, I'm going to sketch it. Okay, my median, excuse me, was like that. And then I'm going to label all this stuff. So where do I get my 5-number summary? From my one variable stats, which I already ran. I should have written it down. Okay. So I've got, my min is 3, my max is 11, my median is 6.25, Q1 is 6, Q3 is 8, and these are all hours. Please don't forget your label. Okay, so done. Looks pretty symmetrical. We're good to go. Okay, now let's do the do. Now again, remember this is a t-score, just like a z-score, so we're going to do our sample mean minus the mean of our hoe divided by standard deviation of our sample over the square root of our sample size. So the mean of my sample was 6.64 minus the mean of my null hypothesis, which was 8. Let's see, over 1.98 divided by the square root of 28. Throw that in the calculator, and we get negative 3.63. Now this was a less than, so this is a one-tailed test, so I always like to draw it. So here's my 8, here's my 6.64, so I want that. My t-score is right here, okay, and there's my one-tailed test. So I only really need to do my t-CDF. Oh, but of course I need my degree of freedom, which is 28 minus 1, which is 27. Always note that somewhere, okay. So let's see. Second vars, there's my t-CDF. Again, lower bound is negative infinity, upper bound is negative 3.63. Degree of freedom is 27. Let's see, negative infinity to negative 3.63 and then 27 gives me a p-value of, 5.8 times 10 to the 4. So 5.8, times 10 to the negative 4. So that's like that. So I'm going to round it to that, okay? Our p is 0.0006. It's essentially 0, okay? So, don't read my conclusion yet. So let's check p against the alpha, okay? And our alpha was 5%. So our p-value is 0.006. Is that true? Why, yes it is. Okay, that's definitely less than that. So our p is low. Okay, our p compared to our alpha, our p is less than alpha. So therefore it's statistically significant at the 5% alpha level. So we can reject the hoe. So if we reject the hoe, we do have convincing evidence that the true population mean number of hours of sleep students are getting at this college is less than 8 hours per week. Okay, or 8 hours per night. Excuse me, 8 hours per week. That's crazy. Okay, so again, the p-value 0.006 is less than the alpha of 0.05, and it is statistically significant at the 5% alpha level, so we reject the hoe. Therefore, we do have convincing evidence for the ha, so we have convincing evidence that the true population mean number of hours of sleep students at this college are getting is less than 8 hours per night, okay? Now, let's just look at a confidence interval, okay? Our confidence interval that would match this would be a 95% confidence interval. So if I run a 95% confidence interval, let's see, before we do that, let's run this in the calculator too. I always want to make sure we got it right. So to do my t-test, okay, now remember, I ran one variable statistics. So my mean and my standard deviation and my sample size got dumped in. I could come over to data, and again, it'll just grab all the data. The only thing I have to fill in is the value of my hoe because they don't know what I'm testing it against. I like this one because I can see everything. So the mean of my hoe was 8 hours. So now I'm going to test my sample mean against that, my standard deviation, my sample size. Now I do have to change the sign for the alternative hypothesis. It should be less than. Okay. And of course I always like to draw it because then it looks like my picture. Can you see? Oh, I got my box plot still stuck in there. Oh, wow. Well, the p-value is so low, it's like we barely see anything shaded. It's so, 1, 2, it's past 3.5 standard deviations. So there's my my t-score, negative 3.63, and there's my p, 6 times 10 to the negative 4. Okay, so we know we got it right. All right, let's compare this again. We do have convincing evidence that the true mean number of hours of sleep students are getting is less than 8 hours. So if we run a t-interval, and of course everything should still be in there, my mean standard deviation, I just got to change, my confidence level is correct. You'll notice that we had convincing evidence that the true population mean number of hours of sleep students were getting was less than 8 hours, and you'll notice they're all less than 8 hours. The entire interval is less than 8 hours. So again, our 95% confidence interval matches our conclusion to a significance test at the 5% alpha, okay, because it's all less than 8 hours. 8 hours isn't even, if 8 hours was in the interval, we would have failed to reject the hoe, but we didn't. That's it for that one.